Okay, so for part E, when is the particle's acceleration 0? So acceleration is the derivative of velocity, right? So we already established for this problem, acceleration is going to be the slope of this graph, because it's the derivative of velocity. So basically, for the acceleration to be 0, we're trying to figure out when is the slope equal to 0. Now again, you need to pay attention to what graph you're given. Because in the next problem we look at, we're going to be given the graph of position. So in position, slope is not going to be acceleration, it'll be velocity. So you have to keep all of that in mind when you're doing these problems. Alright, so we're trying to figure out when the slope is 0. Well, it's going to happen right here and right here, those two intervals. So from 2 to 3, and from 7 to 9. Right, so that endpoint is included again. That 9 is included. Slope is 0 there, but at this point, at 7, it's not because there's a sharp turn. Left-hand derivative is not equal to the right-hand derivative. Part F, when's the particle's acceleration positive? So that means we're looking to see when the slope is positive. So the slope is positive from 3 to 6. And then the acceleration is negative when the slope is negative. So we have two intervals there from 0 to 2. 0 is included. And from 6 to 7. Two more parts here. Part H, when does the particle move at its greatest speed? So before we look at the problem and try and figure it out, what do you remember about speed from yesterday? It's fast. It can be, it might not be. Speed is velocity without direction, right? So speed is the absolute value of velocity. So it doesn't matter if it's positive or negative, we're just looking at that number, the absolute value of that number. So what is the greatest speed? Looking at this graph, what's the greatest speed? 2, right? Well, it happens up here. For that split second, the velocity is 2, but down here, the speed is 2 also. Even though it's negative 2 for the velocity, the speed would be positive 2. So this happens at t equals 0, and the interval from 2 to 3. And that's included, because at 2, the velocity is negative 2, so the speed is 2. And at 3, the speed is also 2. So those are brackets. Those are included. And then our last part, I, when does the particle stand still for more than an instant? So standing still, what does that mean? Velocity is 0. All right, so the velocity has to be 0, but it's saying that for more than an instant. Well, we know the velocity is 0 right here, but that's just like an instant. It changes quickly. All right, the velocity is 0 there for an instant. But over here, the velocity is 0 for an extended period of time. All right, so that happens from 7 to 9. And those are brackets for that because velocity is 0 at 7, velocity is 0 at 9, so those are included in that interval.